solution laws. In this video we'll talk about mass percent composition. In the next videos we'll cover percentage concentration for the solution, ppm and ppb. Before we talk about percent composition for an element, let's understand the idea of the percentage. Here example, we have a container that contains what? 32 balls, 16 green balls and 16 blue balls. We want to find the percent for green and also for blue balls. So for green balls is equal to green balls over total balls multiplied by 100%. So this is equal to what? Green balls over green plus blue balls. 16 for the green balls over 32, which is the total number. So the answer will be 50%. The same for blue balls. Blue balls over the total number of the balls in the container multiplied by 100%. So that blue balls over green plus blue balls, 16 over 32, 100% give us 50%. So now we know the percentage of each, or for both blue and green balls. And this is correct, that the green balls here we have what? 16, which is the half amount of the container. And about that why we found here 50%. The same for the blue balls, 16, which is the half amount of what? Of the container. Now we have mass percent composition. Mass percent composition, we use it to what? To calculate the percentage of an element in a specific compound. Here we have three examples for compound. NaOH, sodium hydroxide. Let's say we want to find the percentage of the hydrogen in this compound. We have sulfuric acid. Let's say we want to find the mass percent for the silver, which is S, and also for chlorine in sodium chloride. So the law for finding the mass percent for an element is what? Mass of element over mass of compound, both in gram unit, multiplied by 100%. Here we have just a small example, water compound H2O. So to find the percentage for oxygen in water compound, so we write the law first, mass of element over mass of the compound by 100%. So that means mass of oxygen over mass of H2O for water, 16 over 18, 100% give us 88.89%. For the hydrogen is the same, this law. So here we write mass of hydrogen over mass of H2O. So this is for hydrogen and this is for O. Just keep in mind here we have H2, so 2 multiplied by 1 for the hydrogen atom give us what? 2. So about that we write 2 here at the numerator. So the answer will be 11.11% for hydrogen atom. The sum for both oxygen and hydrogen must be 100%. So 88.89% plus 11.11% is equal to 100%. So this is your answer is correct. If you want to check your answer is correct or not, the sum of the percentage for all elements that you found, here we have for water 2, for both oxygen and hydrogen is equal to what? 100%. Here you have one example for mass percent composition. Find the mass percentage for NaHC and O and sodium bicarbonate NaHCO3. We have 3 steps to find what the percentage you can set, or mass percent composition for 4 elements in sodium bicarbonate compound. So first step, we need to find the molar mass for each element. After that we can find the molar mass for the sodium bicarbonate. So here we have 4 molar mass for 4 elements, which is for sodium 23, for hydrogen 1, carbon 12, and for oxygen 16. Then we can find the molar mass for the sodium bicarbonate. We covered it before, how to find molar mass in the compound. So here we have 23 gram per mole, 1, 12 for carbon, and here 48 for oxygen atoms, because we have here 3 oxygen atoms. 3 multiplied by 16 give us what? 84.01 gram per mole. In the next step we convert from what? From the gram per mole unit to the gram unit. So the idea is following, that 1 mole of specific element give us what? This amount of gram. That means 1 mole of Na is equal to 23.0 gram. And this is the same number for molar mass. You can see here at the top, or the first step. But rather than we write gram per mole, we write in gram. So this is like the idea of this step is to convert it from gram per mole unit to what? To the gram. And this is we can use this like equation or rule how to convert it from gram per mole to the gram. And the same for the hydrogen 1 mole of hydrogen is 1, like you can see here, gram per mole, but we write here gram. The same for carbon and the same for oxygen. Also the same for the sodium bicarbonate compound, that 1 mole of this compound give us 84.01 gram. As you can see here, we have gram per mole, but here we write it in gram. So why we converted from gram per mole to the gram? Because if you see that in the law, to find the mass percentage for an element, we have for both mass of element as the numerator and denominator in gram unit. So about that, why we converted in the step number 2. So to find the mass percentage for the sodium, 23 gram over 84.01 gram, multiplied by 100% give us 27.38%. For hydrogen, the same for carbon and for oxygen, we can find the mass percent for each element in sodium bicarbonate compound. To check your answer is correct or not, the same as we did for water compound, we sum the 4 percentage for 4 elements must be is equal to what? 100%, that you can see here. After we sum the 4 elements, or the percentage for the 4 elements, we will get what? 100%. Now we'll use program to find or to solve this example by using what? ChemCalculator app. So now we open the program, select English, start, then we have percentage consideration the fourth, and we have here the first bottom, which is for mass percent or percentage composition. So for percent composition, we click on M percentage, and here we write for what? For, let's say for oxygen we have 16, and for water is 18, give us what? 88.89, which is this. The same for the hydrogen, we have here 2, give us 11.11%. Also for this example, you can see for 4 elements. For the sodium, we can see here 23, and for the sodium bicarbonate is what? Is 48.01, give us what? 27.38. Let's say we want to find for oxygen. So oxygen here we have what? 48, and you can say the denominator is the same, because we have which is the molar mass for sodium bicarbonate, so give us what? 0.136, which is 1,4. Thank you for watching, and in the next video we'll talk about percentage consideration for what? For the solutions.